Welcome to aminacademy.com. In fluid mechanics regarding dimensional analysis, let us do some introduction. Dimensional analysis is a method of dimensions. It is a mathematical technique used in research work for a design and for conducting model tests. It deals with the dimensions of the physical quantities involved in the phenomenon. All physical quantities are measured by comparison, which is made with respect to an arbitrarily fixed value. Basically, length is L, mass is m, and time is t, or three fixed dimensions which are of importance in fluid mechanics. If in any problem of fluid mechanics heat is involved, then the temperature is also taken as a fixed dimensions. These fixed dimensions are called fundamental dimensions or fundamental quantity. Here, these are fundamental quantities: length, time t, mass m, current ampere is I, temperature theta. These are somewhat fundamental quantities. In that, length, time, mass, and temperature is a basic quantities for fluid mechanics. We quantify a size and shape of things using dimensional analysis. It helps us study the nature of object mathematically. It involves length and angles as well as geometrical properties such as flatness and straightness also in other than fluid mechanics. The basic concept of dimension is that we can add and subtract only quantities with the same dimensions. Similarly, two physical quantities can be equal only if they have the same dimensions. Or here, secondary dimensions, that is secondary or derived quantities. Secondary or derived quantities. Those are quantities which possess more than one fundamental dimensions. For example, velocity. Velocity is that meter per second. In that, in dimension, it gives L over T. Then we can write this as L T power minus 1. Like that, we can derive lot of secondary dimensions. We know that area, meter square, this is L square. Volume, meter cube, that is L cube. That kinematic quantities, acceleration, meter per second square, which is equal L T power minus 2. Angular acceleration, omega, which is equal angular acceleration, not omega, angular alpha it is, which is equal per second, it is T power per second square, T power minus 2. Discharge of water, that is meter cube per second, which is equal L cube T power minus 1. Gravity, acceleration due to gravity is, that is G meter per second square. Kinematic viscosity, Kinematic viscosity equal L square T power minus 1. Dynamic quantity force is Newton, and that ml T power minus 2, mass into acceleration, force. Weight is of course a force, ml T power minus 2. Density is rho kg per meter cube, that is m L power minus 3. Density, specific weight or specific weight m L power minus 2 P power minus 2. Dynamic viscosity is mu, which is equal m L power minus 1 P power minus 1. Pressure intensity is equal m L power minus 1 P power minus 2. Modulus of elasticity modulus of elasticity is m L power minus 1 P power minus 2. Surface tension is m T power minus 1. Surface tension m T power minus 2. Shear stress tau equal m L power minus 1 T power minus 2. Shear stress next work energy both are have same unit which is equal m L square T power minus 3. Power P equal m L square t power minus 2. Torque is t equal ml square t power minus 2. Power is t power minus 3 here. Work energy ml square t power minus 3. Work energy is ml t power minus 2 here, minus 2. Shear is also same. Power is ml square t power minus 3 here. Then torque t equal ml square t power minus 2, and momentum equal ml t power minus 1. These are the some derived dimensional quantities, but this I give here only the formulas, but we can derive, if you need we can derive in solving problems. These things we can solve. Now next is, look at here, next is dimensional homogeneity. What is dimensional homogeneity here? Dimensional homogeneity means the dimension of each term in an equation on both sides are equal. Thus, if the dimensions of each term on both sides of an equation are the same, the equation is known as dimensionally homogeneous equation. The power of fundamental dimensions, that is LMT, on both sides of the equation will be identical for a dimensionally homogeneous equation. Such equations are independent of the system of units. For example, V equal velocity equal, you know that, square root of 2gh. Both sides we get a dimension. V velocity dimension is L e power minus 1 equal square root of 2g. Dimension of g is L power t minus 2, h is L. So which is L t power minus 1. Which is equal, g is square root of 2 L square t power minus 2, which is equal square root of 2 and square root of L square t power minus 2 is L t power minus 1. So which is equal square root of 2 L over t. Here L t power minus 1. Look at here, both sides the dimension is L t power minus 1, here L t power minus 1, but root 2 have no dimension. So it is dimensionally homogeneous. So we can prove it is dimensionally homogeneous. These two quantities is both side LHS and RHS is equal dimensions. So it is called dimensionally homogeneous. So far we discussed about dimensional analysis, basic things, that is what is dimensional analysis, what is the basic units, and as well as secondary units. or derived quantities we have done. Please subscribe our YouTube channel.